Hey geometry team, welcome back to our unit on using right triangles. And today we're going to be finding missing angles of triangles using trigonometry. And so we had our three trig ratios, sine, cosine, and tangent. And so far, every time we've used those, we've known the measure of the angle that we were doing the sine, cosine, or tangent on. Today, we're going to be figuring out what to do when we don't know the angle that is being sined or cosigned or tangent. And if you think back to when you did algebra, if we wanted to undo something for a problem, if I wanted to undo a times 3, the inverse of timesing 3 was dividing by 3. And that's what we would do to both sides of the equation. The inverse of adding something, so if x plus 5 equaled 10, the inverse of adding was subtracting. And that's what we would do to both sides of the equation. If we had something squared, then to undo a square, the inverse of squaring was square rooting. Okay? Well, for our trig functions, the inverse of our trig functions have their special signs. So the inverse of sine is the inverse sine, and the way we write that is written as sine exponent negative 1. It does not mean the same things you would normally think of an exponent as meaning. It's just a way of writing it. It's just a notation. So if you see sine with a negative 1, that just means inverse sine, or the opposite of a sine. If you want to find the opposite of cosine, that's called the inverse cosine, and it's written cosine with a negative 1, or cos negative 1. But we say it as inverse cosine. It looks like an exponent, but we read it as inverse cosine. The inverse of our tangent function is inverse tangent, so it looks like tangent negative 1, but we say it as inverse tangent. Okay? And so to use this, we're going to use it in our calculator. And if you're doing it in your calculator, first of all, always set your calculator in degrees because we don't use radians. If you're wanting to do it, okay, anytime you want to do the inverse of sine, cosine, or tangent, it's the little symbol just above them on your calculator. And so you're going to press the second button and then sine. So if you want to do the inverse sine, you're going to have to press second, and then you're going to press sine to make this show up on your screen. Same with cosine, same with tangent. Okay? If you have a phone, which I truly do not recommend using unless you're just absolutely desperate, you're going to put whatever you had in there ahead of time. If you want to do the inverse sine of something, you're going to press the second and then this here. But again, the other stuff that gets entered is entered differently than it is in your calculator, so I really don't recommend using this unless you're extremely comfortable typing things in, not the way you see them on your paper. Okay? So to see how you use the inverse ratios, what we're going to do is we're going to be given a problem. Okay? I don't know this angle at all, but I do know that I have the side opposite my angle, and I have the hypotenuse of the triangle. And so I think of my SOHCAHTOA is my shortcut for remembering sine, cosine, and tangent. If I have opposite and hypotenuse reminds me to use the sine because it starts with S. And so I'm going to be doing sine of my angle, which I don't know. I don't know what the sine of that is, so it's sine of x, but I know I can set up the numbers. I'm going to use opposite and hypotenuse. So the opposite is 9, and the hypotenuse is 14. And so now I've set up this thing. Well, I don't want to know what the sine of x is. I want to know what the inverse, I want to know what just x is. So I need to unsine my x. So to get the sine off of my x, I need to use the inverse sine. So to do that, you're going to put your inverse sine onto my sine. But if I inverse sine the left, I need to inverse sine the right. Okay? So we've still done the same thing to both sides. I'm just going to do whatever inverse sining does. And it's a mystery thing that you don't have to understand. Just know it's the opposite of sining, and it's something your calculator can do for you. And so you'll have your calculator, which I left mine over here, but here it is, okay? And so you will have it, and you're going to go, okay, if I inverse sine the sine, that's going to go away, and I'm going to be left with x. Over here, I need to do the inverse sine of this fraction. So in my calculator, I'm going to do second and sine, and it pulls up inverse sine, which you can't see because it's not bright enough right there. But it's going to pull up the inverse sine of 9 divided by 14. And when I put that in my calculator, it tells me that that comes out to be 40.005 is my x. So x equals 40.005. And I will usually tell you how many decimal places I want if I want you to do it to the tenths or the hundredths or the thousandths, okay? You're always going to be getting some kind of decimal. I will tell you how much you want. So we use the inverse sine to remove the sine from your angle, okay? So you go, okay, let's try another one just to make sure we weren't imagining things. So again, I've got a triangle. I'm trying to find this angle. I don't know what it is. So look at the parts of the triangle you have. I have a hypotenuse, and I have the opposite side from the angle I want. If I have opposite and hypotenuse tells me to use sine. So I'm going to say, okay, the sine of my mystery angle is going to be the opposite over the hypotenuse. And then you remind yourself, I don't want x to be signed, I want x to be by itself. So to remove that sine, I need to do the inverse sine. But if I inverse sine the left, I have to inverse sine the right. When I do that, I'm going to get x equals whatever the inverse sine of 31 over 38 is. And so this is going to be what I put into my calculator. So I'm going to hit second and sine. My calculator just died. So I hit second and sine and get whatever it's supposed to be. And wouldn't you know it, it comes out to be 54.67 degrees. And so that told me what my angle was by using the inverse sine in your calculator. Okay? And it doesn't just work with the sine function. The beautiful part is we can inverse all of our trig functions. So if I have this problem now, I am still looking for a mystery angle. I still have a hypotenuse, but this time I have the side that's adjacent to my angle. And so when I'm going to use an adjacent and a hypotenuse together, that tells me I'm going to use cosine. And so over here, I know I'm going to want to do the cosine of my mystery angle, and that it's going to involve the adjacent and the hypotenuse. So 44 over 52. And so we need to get the cosine off of my x. It's not times by x. Cosine is being done to the x. So to remove the cosine, I need to do the inverse cosine. And the inverse of cosine, we type cosine -1. But if I inverse cosine the left, I have to inverse cosine the right. The inverse and the cosine cancel out, and you're left with just plain x over here on the left. And then I'm going to have my inverse cosine of 44 over 52 here. So this tells me exactly what to type into the calculator. So I'm going to second and cosine now the 44 over 52 fraction. And when I put that in, x comes out to be 32.2 degrees for my angle. And so using the inverse takes off the regular trig function. Trying another one here. You go, okay, I've got a mystery angle that I don't know, but I do have a hypotenuse of my triangle. And then for the angle I don't know, I have the side adjacent to it. When I have adjacent and hypotenuse, SOHCAHTOA reminds me to use cosine. So I cosine that mystery angle that I don't know, and I'm going to put in my adjacent. Ooh, you can't even tell that that's a 19. Mrs. Cerna, you got to do better than that. 19 and 24 are your numbers. I don't want the cosine of x though. I just want plain x. So to remove the cosine, I'm going to use the inverse cosine. But if I inverse cosine the left, I've got to inverse cosine the right. And so the cosine and the inverse cosine cancel out. I'll just be left with x. Over here, I know to put in the inverse cosine of 19 over 24. So I'm going to second and cosine, and then I'm going to put in 19 24ths as the number inside the parentheses, hit enter, and I get x turns out to equal 37.66. So I found my angle using the inverse operation for my cosine. Another. So we move on. And now I've got an angle that I don't know. I don't have my hypotenuse at all on this one. Instead, I have the angle that's opposite my mystery angle, and I have the angle that's adjacent to it. Do you notice how I'm always filling things in on the picture? This is very helpful to keep you straight on what did I exactly find and how does it all relate. If you try and do too much of this in your head, you're going to mix things up. So I highly recommend drawing the pictures. Save yourself the grief of getting things confused. So you go, if I'm using adjacent and opposite now, adjacent and opposite are both in TOA from my SOHCAHTOA, so I know I'm going to be using tangent. But I don't know what my angle is, so I'm going to say, well, the tangent of x. I don't know. But I know my adjacent and opposite are 21 and 25. So my opposite is 21, my adjacent is 25. So the tangent of x is this fraction, but I don't want the tangent of x. I just want x. So to untangent this, I need the inverse tangent. If I inverse tangent the left, I'm going to inverse tangent the right. These will cancel out because they're inverse operations, and I'm left with just x equals whatever the inverse tangent of 21 25ths is. This is where you get your calculator now because you don't know what this is, but your calculator does. And you will go inverse tangent of your 21 25ths and hit enter, and you end up with the x equaling 40.03 degrees. So now we've used our sine and our inverse sine, our cosine and our inverse cosine, and now we've used our tangent and our inverse tangent. Do I have one more example of my tangent, or do I move on to something even more fun? Yep, we've got one more example. Got to do two of each. Got to be fair. Don't want to leave poor tangent out. And so you go, okay, mystery angle. I don't have the hypotenuse. I have the opposite side and the adjacent side. So opposite and adjacent tells me to use the tangent with the opposite and adjacent. So my tangent of my mystery angle is going to be the opposite over the adjacent. To get the tangent off of my x, I need to inverse tangent. So I need to inverse tangent both sides. So x is going to equal the inverse tangent of 6/10. So I'm going to inverse tangent 6/10, and I'm going to come out with 30.96 as my number of degrees for this particular angle. So remember, to get any trig function off of your mystery angle, use the inverse trig function that goes alongside it. And so to go forward with this now, we're going to talk about, with word problems, we have something called angle of elevation and angle of depression. Since we're finding angles in triangles, this is a real-world application of that. An angle of elevation is the angle you look up from a horizontal surface. So maybe from the level of your eyes, maybe from the ground, but it's an angle looking up. If you've got an angle where, oops, I did not mean to skip ahead. You don't see that. You don't see that. You don't want to get cheated. Come here, little mouse. There we go. Yeah, you can't give you stuff ahead of time. No spoilers. So you go, if you have a level amount and you have your angle looking down, so maybe from your eyes to the ground, or the angle looking from an airplane down at the ground, something where you're looking down is an angle of depression. So elevation looks up, depression looks down. And so you use that to solve problems in your, whatever word problem you got. So you go, okay, the angle of depression from this bird sitting on top of the telephone pole is 72 degrees. So the top of the pole to the base of the tree, this depression angle goes down, and it's 72 degrees. Okay? The telephone pole, we're going to assume it's vertical, straight up and down, so it should make a right angle. And we're going to say that that is 20 feet tall. And we want to know what's the distance between the pole and the tree. Well, you'll notice I don't have the angle of this triangle here. I have this angle of depression, but my right triangle that I want to use to find this mystery distance doesn't actually have an angle in it. But you can use your understanding that the angle here is going from a level line and the ground is level, so these are parallel to each other. And parallel lines create alternate interior angles. Oh, that's from back that other unit, right? And alternate interior angles were congruent. So this angle of depression equals this angle here. So now I can use this 72 degrees down here to find the stuff inside this triangle. Well, I want to find this side, which is going to be adjacent to my 72 degree angle. The side that I know, the height of the pole, is opposite my 72 degree angle. So if I have opposite and adjacent, that tells me to use the tangent. And I know that it's 72 degrees. And so I'm going to be using my opposite is 20 and my adjacent is x. Okay, so doing that, oh, I know my angle. I don't have to use my inverse function here because I already know my angle. I just need to get x by itself. I've got a divided by x. I don't want x to be on the bottom of my fraction, so I'm going to times x on both sides. That removes the x out of the fraction and puts it over here so that I have x times the tangent of 72 equals 20. And then you go, well, I don't want x times the tangent of 72. I just want x. The inverse of timesing by a tangent is dividing by a tangent. See the difference with the inverse? The inverse is untangenting, but the opposite of multiplying by a tangent is dividing it. And then I'm going to divide it on this side. And so my mystery side is going to equal whatever 20 divided by the tangent of 72 is. And so I'm going to put that in my calculator, 20 divided by the tangent of 72, and it comes out to be 6.498, blah, 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 so about 6.5. Alrighty? And so we have found this distance using our trigonometry. That's how you find a side in a word problem using our trig stuff. But we aren't always finding a side. So I put in the numbers here and forgot that I put them in, so it was getting all filled in and I didn't need to do anything with it. So let's click this through and go to my next problem. You recognize this building? You should. It's World Trade Center, One World Trade Center. So the angle of elevation, so an angle looking up from a park bench, 332 feet from the base of the World Trade Center. So I'm 332 feet from here, and I've got a 41 degree angle of elevation here. And they want to know, how tall is One World Trade Center? I don't know, but you can figure it out. And so, again, I have been given my angle, and I have an adjacent side, and I'm looking for the opposite side. Opposite and adjacent is going to be tangent. So I'm going to use the tangent of the angle. I know this angle. It's 41. And so my opposite is how tall the World Trade Center is, and my adjacent is the 332 feet distance away from it. So now I can times by the 332 on both sides so that I'll have x by itself. And over here, I just need to find out how much it is using this guy. So I'm going to put 332. You can put times tangent or just hit the tangent because it knows it's multiplied if it's right next to it. So the tangent of 41. And that comes out to be 288.6. And so if you're thinking 288.6, I don't know what the 288.6 is, but however tall it is, that's how tall it is. I think the numbers on here aren't actually real life numbers, just so you know. And so this would be how you would find that missing side. If you had missing angles, you would use your inverse tangent. But the important thing here is to recognize that angles of elevation are looking up. Angles of depression, like the previous problem, are angles looking down from a level. Good luck using your trig functions and your inverse trig functions. Have a great day.